The question we are solving now belongs to test series 3. It is of signals and systems subject. In specific, it belongs to sampling. As per the question, there is a signal x of t is equal to cos of 100 pi t. It is sampled at a frequency of omega s is equal to 150 pi radians per second. It is given that the sampled signal is reconstructed using a low-pass filter of cutoff frequency omega c equal to 75 pi radians per second. We need to find the output of the low-pass signal, that is xr of t. From the given data, we see that the signal that is sampled is x of t is equal to cos 100 pi t. We know that this signal cos 100 pi t has the frequency representation as two impulses, one at 100 pi radians per second and other at minus 100 pi radians per second. From this, we see that the frequency domain representation of x of t can be shown as shown. It contains an impulse at minus 100 pi and 100 pi. Now it is given that this signal x of t is sampled at a sampling frequency of omega s is equal to 150 pi radians per second. Due to the sampling, we know that the frequency spectrum will be a convolution of the original frequency spectrum with a impulse train, which are separated by 150 pi radians per second. From this, we see that there is a spectrum which is centered at 0. Then there is another spectrum which is centered at 150 pi radians per second, because of which there will be two impulses, one at 50 pi, similarly another one at 250 pi. Similarly, there is a spectrum which is centered at minus 150 pi, due to which there will be a spectrum at minus 50 pi and minus 250 pi. We can proceed similar way to actually get an idea about the frequency domain representation after sampling. Now it is given that this signal is passed through a low pass filter of cutoff frequency 75 pi radians per second, due to which we will be left with only two impulses, one at 50 pi radians per second and other one at minus 50 pi radians per second. Hence, finally the signal that is reconstructed can be written as cos of 50 pi t due to impulses at 50 pi and minus 50 pi. Please note that during the complete analysis, we assumed the magnitude as k, and the constant k factor remains the same. Hence, finally the reconstructed signal xr of t can be written as cos of 50 pi t. So from this, we see that the correct option representing the reconstructed signal is D.